This video is going to be an introduction to using the law of sines. The law of sines can do two things. It can find the length of the side, it can find the measure of an angle. This formula is not really going to consist of all three fractions and two equal signs. It's really just going to be two equal fractions. And once we have that set up, we can cross multiply and solve what we need to. Today we're going to focus on using the law of sines to find the length of the side. First example says triangle ABC. Little a is 10, measured angle is 30, measured angle B is 50. We're going to find little b to the nearest integer. First thing I would suggest we do is draw our picture. I'm going to label it as triangle ABC. And I'm looking at the information given. I know little a is 10. I know the measure of angle A is 30, measure of angle B is 50, and we're looking for little b. Now we're going to notice if we take a good look that we have two angles and we have one side. If I see that information, I'm going to say that I have angle, angle, side, and that's my indicator that I'm going to use the law of sines here. Really important, the 10 and the 30 are going to be paired up in one fraction. I'm going to say that I have 10 over the sine of 30 is equal to, and the little b is going to be paired up with the 50 degrees, so it's little b over the sine of 50. Once I have my proportion for a fraction equals a fraction, I'm going to cross multiply. When I cross multiply, I'm going to take the bottom left and multiply by the top right. That'll be b times the sine of 30. And I'm going to take the top left, multiply it by the bottom right. That'll be equal to 10 times the sine of 50. Our goal here is just to get little b all by itself. Now keep in mind that the sine of 30 is the same thing as 1/2. So this says 1/2 times little b is equal to 10 times the sine of 50 degrees. To get little b all by itself, I'm going to multiply both sides by 2. When I do that, I'll take my calculator, do some multiplication on that right-hand side, enter it in exactly as I see it, 2 times 10 times the sine of 50. That's going to give me an answer of 15.3209. Now, please make sure you go back. It does say that our answer should be to the nearest integer. Therefore, little b is going to be equal to 15. Next example. Same basic idea. We're told we have triangle ABC. So again, I'm going to draw it. I'll call it A, B, C. We're told that little a is equal to 12. We are told that the sine of a is equal to 1/3. Now that information is a little bit different. It's not the measure of the angle we're given. We're given the value for the sine of it. Same thing, we're told the sine of c is equal to 1/4. Once again, if you look, I do have two angles and I do have one side. So if I have angle, angle, side, that's my clue that it's a law of sines question. Now we're looking for little c. So I'm going to set up my proportion. I'm going to say that little a over the sine of big A is equal to little c over the sine of big C. Now the next part of this question is really important. I'm going to sub in my numbers where they belong. I know that little a is 12, and I'm told that the sine of A is equal to 1/3. So this 1/3 is going to go in for the sine of A. That's going to be equal to little c, which is what we're looking for, and that's going to be divided by the sine of c, which again, we were told the sine of c was 1/4, so that 1/4 goes in for the sine of c. It's not the measurement of c, that's the value for the sine of c. Just like our last question, we're going to go ahead and cross multiply. Fraction equals sine fraction. If I take the bottom left and multiply by the top right, that gives me 1/3 of c is equal to, I'm going to take the top left, multiply it by the bottom right, that's going to be 1/4 times 12, which is going to be 3. Again, I'm going to divide both sides by 1/3 or multiply both sides by 3. That's going to give me the little c is going to be equal to 9. In my next example, we're going to look at a Regents question. Came off of an old Regents exam. It's multiple choice. Again, I'm going to look at the question, accompanying diagram, approximate linear distance traveled by a sailboat during a race. Sailboat started at point S, traveled to point E and A, respectively, and ended at point S. Based on the measures shown in the diagram, which equation can be used to find x, the distance from point A to point S? Now, it's multiple choice, so I would suggest a little process of elimination. Right off the bat, I know that it's not going to be choice A and it's not going to be choice D. The only way this information could possibly help me to find the length of the side is if I have one of my trig functions. And I don't see any trig functions in those choices. I can't just set up proportions and cross multiply. It doesn't work that way. If I take a good look at what the information I was given, I notice that I do have an angle and a side across from it, and same thing here, I have an angle and a side across from it. my thought is I have enough information to use the law of sines. So I'm going to say that x over the sine of 65 is going to be equal to 32 over the sine of 75. Once I have that proportion set up, I can look at my choices, figure out which one it is. Although it's not exactly the same, it's flipped upside down, the appropriate answer is going to be letter B. If you think about it, if I were to cross multiply here, I would take x and multiply it by the sine of 75. Same thing here, I would take x and multiply it by the sine of 75. And then for the last part, I would take 32 and multiply it by the sine of 65. Since these pieces all line up, it's the same proportion, even though it's upside down. Our last example, again off of an old Regents exam, says ski lift begins at ground level, 0.75 miles from the face of a mountain whose face has a 50-degree angle of elevation, as shown in the accompanying diagram. The ski lift descends in a straight line at an angle of 20 degrees. Find the length of the ski lift from the beginning of the ski lift to the top of the mountain. All right, so here's what we're looking for. We would like to find the distance from the beginning of the ski lift to the top of the mountain, so I'm going to call that x. Now, if I look at my picture, I do have some information missing. I was told in the question that the distance from the beginning of the ski lift to the base of the mountain, that was that 0.75, and that's important. If I look even closer, I'm going to notice that this angle here is a linear pair with the 50 degrees. So if this angle to the right is 50 degrees, my angle that's inside the triangle has to be 130. We should also know that the sum of the angles of the triangle is 180 degrees. So if this angle is 20, this angle is 130. That means that my angle up here at the top right is going to have to be 30 degrees. Now, I'm always looking for sort of indicators as to whether it's a law of sines or law of cosines question. And in my experience, when you have lots of angles, like we do in this question, it's going to be a law of sines question. Again, I could also say that I do have an angle, and a side. I have lots of angles, and I do have that one side. Now it's just a matter of setting up the proportion correctly. What I would suggest we do is just carefully go through and look at the parts that we have. We know that we would like to find the value of x, so obviously I need to use these two pieces. So I would say that I have x over the sine of 130 is equal to, and since the 0.75 is the only other side that we know, I'm going to have to use that as well. So I would say that that's 0.75 multiplied by the sine of 30. Once I have my fraction equal sign fraction, again, I can go ahead and cross multiply. I'll take x and multiply it by the sine of 30. Now, as we've said, we know the sine of 30 is a half, so that's really going to be 1/2 times x is equal to. And then I'm going to take 0.75 and multiply it by the sine of 130. So 0.75 multiplied by the sine of 130 degrees. All right, so time to get x all by itself once again. I'm going to go ahead and multiply both sides by 2 to get rid of that 1/2. And when I do that, I can plug it right into my calculator. 2 times 0.75 times the sine of 130. That's going to give me an answer of 1.14906. Now the directions again are really important. It does say to round to the nearest 1/100th of a mile. 100th of a mile is 2 numbers to the right of the decimal point. So x is going to be equal to 1.15. Very important. Law of sines can be used to do two things. This video covers one of them. The next video will cover how to find the measure of an angle.